Hello everyone, welcome to my YouTube channel. So for today's video, we will be having our discussion on the biochemical perspective to medicine. So this is our fourth PowerPoint in our schoology course. So we're supposed to have our Zoom today, but since we're having a hard time with the weather, and of course that causes the weakening of our internet connection, that's why I decided that I will just film myself while doing the discussion. Okay, so you can watch it on YouTube through your schoology course. Okay, so let's start. So the word biochemistry has developed as an offshoot of organic chemistry, and this branch was often referred as the psychological or physiological chemistry. And the term biochemistry was coined by Newberg in 1903 from the Greek word bios, which means life. Definitely you've learned that in your biology 101 and even way back high school. And you have the term kymos, meaning juice. Okay, the practice of medicine is both an art and science. So the word doctor is derived from the Latin root docere, which means to teach, meaning if you are a doctor, you are also expected to teach. But that's what doctors do also. They also teach their patient what to do. Okay, they also teach, the patient or their patient about proper hygiene and a lot of things relating to health. Right? And Hippocrates from 460 BC to 377 BC, he is considered to be the father of modern medicine, and he articulated the oath, okay, the oath for doctors, okay, in which you cannot deprive a patient, or you cannot deprive a person regardless of his social status, regardless of his appearance or whatever. You cannot deprive him of health or help, medical help. You cannot deprive him of medical help. And so once you take that oath, you really have to to serve your purpose as a doctor. And so we have the milestones in biochemistry. You have there also in your PowerPoint presentation popular persons in biochemistry. Okay, so yun na lang, just go over it. Then we have the biomolecules. So we have the four essential, or the most essential biomolecules in our body. We have four, or major biomolecules. We have the protein, lipids, nucleic acid, and carbohydrates. So more than 99% of the human body is composed of 6 elements, particularly oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. And human body is composed of 60% water, 15% protein, 15% lipids, and 2% carbohydrates, and the 8% remaining is that of minerals. So the building block of protein, or the building blocks of proteins, are the amino acids. So we have thousands of amino acids, but we have 20 essential amino acids, which we will discuss in our lesson about proteins. Then we have the lipids, which are made up of fatty acids. So building block of lipids are the fatty acids. Then we also have the nucleic acids, particularly the DNA and the RNA. DNA stands for deoxyribonucleic acid, and RNA stands for ribonucleic acid. The other one is, the fourth one is carbohydrates, which are made up of sugars. And we will also discuss this biomolecules by and by as we go along with our topic on biochemistry. And molecular structures in organisms are built from 30 small precursors, sometimes called the alphabet of biochemistry, and those are the 20 amino acids, 2 purines, 3 pyrimidines, sugars, particularly the glucose and the ribose, the palmitate, glycerol, and choline. So study of metabolic process or study of metabolic processes, we have the primary metabolism, and that is of course the digestion. Okay, so I know you're very particular with digestion already. I know you've discussed it way back grade 8. So yeah, you already know that there are two types of digestion. You have the mechanical and then you have the chemical digestion. So mechanical digestion involves your teeth, your tongue, the breaking down of foods in your mouth. And of course, you have the chemical digestion involving enzymes, gastric juices, stomach acids, and the like. When you say secondary metabolism naman, after absorption, the small molecules are further broken down and oxidized into carbon dioxide. In this process, the NADH or the FADH2 are generated. So tertiary metabolism, finally, this reducing equivalents enter the electron transport chain in the mitochondria. So mitochondria is of course the powerhouse of your cell, where they are oxidized into water. So in this process, energy is trapped as ATP. So as you know, ATP stands for adenosine triphosphate, and that is known to be the energy currency of the cell. And metabolism is the sum of all the chemical changes of a compound inside the body, which includes synthesis, that's also known as the anabolism, and the other one is catabolism, which is also known as the breakdown of larger molecules into simpler one. Okay, the word kata, means down, and the word balain means change. So now let's talk about the stabilizing forces in molecules. So we have two types of bonds. We have this type, covalent bond and ionic bond. And we also have the hydrogen bond, the hydrophobic interactions, and the van der Waals forces. But in this lesson, we will focus on the ionic and the covalent bond. Okay. So when you say ionic bond, when you say covalent bond, molecules are formed by sharing of electrons between atoms. And usually, covalent bonds happen between two nonmetals. Okay? Non-metal to non-metal interaction, wherein those two atoms will share an electron. Like in the case of chlorine. Diba? So chlorine has a valence of 7. Okay, so 1, 2, 3, 4, 5, 6, 7. So chlorine has a valence of 7. So for it to become stable, how many electrons does it need? Okay, again, to become stable. So since there are 7, it only needs 1 electron. So what is our basis for that? So we base that on the Octet Rule. Okay? Octet Rule meaning for an atom to become stable, it should have 8 electrons in its valence. In its valence shell. Okay? So since there are already 7 electrons, we need 1 for it to become stable. So the tendency of chlorine is that it will share with the other electron or the lone electron from another chlorine atom. So this is a chlorine to chlorine bond. Okay, so if you will count the total number of electrons, so 1, 2, 3, 4, 5, 6, 7, 8. In this case, the chlorine is now stable. So the bond that exists between these two chlorine atoms is an example of covalent bond, meaning covalent means sharing of electrons between two atoms or two nonmetals. Now let's proceed to that of the ionic bond. So when you say ionic bond, that means the transfer of electron from one atom to another. Now remember, only the electrons can be transferred from one atom to another since the proton and neutron are found inside the nucleus of an atom. and they cannot leave the premises of the nucleus, or they cannot leave the nucleus. That's why only the electron can be shared or transferred. Now, if you can recall in your chemistry lessons before, okay, we base our atomic number on the number of protons found inside the nucleus. Okay, though in a neutral atom, whatever is the number of proton is also the number of electron. But why is it that we base our atomic number to that of the number of protons instead of electrons? It's because protons do not leave the nucleus, right? While electrons, they can leave the atoms, since they can be shared and they can be transferred. So that's it. Anyway, now let's go to ionic bonding. Now, ionic bonding or ionic bond happens when an electron is transferred from one atom to another, and usually happens between a metal and a non-metal. Say, for example, that of sodium chloride or our table salt. Sodium has only one valence, okay? Or it has only one electron in its outer shell. Okay, now let's have chlorine. So a while ago, we had the chlorine as an example, or two chlorine atoms as an example of, the covalent bond. So you already know that chlorine has 7 electrons in its outer shell, so that's it. So sodium is a metal, while chlorine is a non-metal. Now the tendency, remember how the tendency of a metal is to donate electron. Okay, metals are known as electron donors, while non-metals are known as the electron acceptor. Okay, so tingnan na lang natin. Let's just look at this example here. Now, which one is easier for the sodium? Diba? Which one is easier for the sodium to do to become stable? Will it get the 7 electrons from the outer shell of the chlorine for it to become stable? Kunin niya lahat yung electrons dito, ilagay niya dito para maging stable siya? Or just give away this 1 electron to chlorine for it to become isoelectronic with neon? Okay? Neon, by the way, is neon is a noble gas. Meaning, when you say noble gas, it means its outer shell is already filled with 8 electrons. Diba? Sabi nga natin kanina sa Octet Law or Octet Rule, for an element to become stable, it should have 8 electrons in its outer shell. Okay? So, for the sodium to become isoelectronic with that of the neon, mas madaling i-give up na lang ni sodium ang kanyang isang electron, ibibigay niya na lang sa chlorine. And now, this will become stable. Okay, this is a case of an ionic bond in which there is a transfer of electron from a metal to a non-metal atom. So again, remember, the tendency of a metal atom is to donate electron, while the tendency of the non-metal is to accept electron. Yeah. So I hope you now know the difference between ionic and covalent. So again, when you say covalent, that means the sharing of electron between 2 atoms, and when you say ionic, that is the transfer of a transfer of an electron from one atom to another. And covalent happens, or usually happens, between a non-metal to non-metal interaction, while ionic happens between a non-metal and a metal. Now, the third type of bond is the hydrogen bond. These are formed by sharing of hydrogen between 2 electron donors. Okay, so I have a separate discussion about this types of bonds, no? So our focus today is just the ionic and the covalent bond. And I will have a follow-up video dun sa mga sample solving natin. So I will introduce yung how will you determine whether it's really ionic or covalent based on the chart. Yan. So, I'll introduce a chart in the other video. Okay? Kasi parang sobrang haba na nito. And the other one is the hydrophobic interaction. This one is also very interesting. We will also discuss this in this video, the hydrophobic interaction. We have non-polar groups have the tendency to associate with each other in aqueous environment. And these are formed by interaction between non-polar hydrophobic side chains by eliminating water molecules. So, as we discuss about, our cell membrane, we will be encountering this type of interactions. Okay, I know you've already heard about hydrophobic and hydrophilic. So when you say hydrophobic, they are water fearing, and when you say hydrophilic, they are water loving. Okay, in our next video, don't worry, I will discuss that again. So anyway, review na lang yan, na-discuss nyo na yan siguro, or I'm sure na-discuss nyo na yan nung senior high school kayo. Then we have number 5, the van der Waals forces. These are very weak forces of attraction between all atoms due to oscillating dipoles, described by the Dutch physicist Johannes van der Waals. Yeah, Johannes van der Waals. And now let's talk about water. So you already know water is the universal solvent. It can dissolve basically anything. And water is a polar molecule. Molecules with polar bonds that can easily form hydrogen bonds with water can dissolve in water and are termed hydrophilic. Okay? And the other one is it has immense hydrogen bonding capacity both with other molecules and also the adjacent water molecules. So this contributes to cohesiveness of water. So water favors hydrophobic interaction and provides a basis for metabolism of insoluble substances. Then, water expands when it is cooled from 40 degrees Celsius to 0 degrees Celsius, while normally liquids are expected to contract due to cooling. Okay, so, yan. So, kabaliktaran siya ng solid. When a solid is heated, it expands. Diba? So, yun na yung tinatawag natin na sa thermal expansion, the reason why roads have gaps, not to cater thermal expansion. Kasi nga, like what I've said, the solids will expand when they are heated. But it's different in the case of water because the water expands when it is cooled. Diba? From 4 degrees Celsius to 0 degrees Celsius, or the freezing point of water. So it will expand. So I'll give you an example. If you put what's this? If you put a Coke in can inside the freezer for, let's say, 24 hours, and you will notice it try to open your freezer the next day, then you will notice na your can will expand a lot. So mutambok yung lata. Alright, sorry for the term, but it will greatly expand, and sometimes it will explode inside your freezer. But that's the tendency of it, because like what I've said, liquid or water will expand when they are cooled. But don't do that half. Yung maglagay ng Coke in can or beer in can inside the freezer, because you know already what will happen. And as water is heated from 0 degrees Celsius to 40 degrees Celsius, the hydrogen bond begins to break. And this results in the decrease in volume, or in other words, increase in density. So hence, water attains high density, remember, at 4 degrees Celsius. However, above 4 degrees Celsius, the effect of temperature predominates. Now, let's talk about thermodynamics. So, thermodynamics. Thermodynamics is concerned with the flow of heat. It deals with the relationship between heat and work. So let's talk about the first law of thermodynamics. So the first law of thermodynamics is, what's this? Law of conservation of energy. That's right. The law of conservation of energy. It states that Energy cannot be created nor. Okay, so let's proceed to our second law of thermodynamics. So the second law of thermodynamics states that the total entropy of a system must increase if a process is to occur spontaneously. So entropy, or it is represented by letter S and is defined as the measure of the degree of randomness or disorder of a system. So basically, when you say entropy, it means disorder. So yan yung tatandaan ninyo. While on the other hand, the enthalpy is the heat content of a system, and entropy is that fraction of enthalpy which is not available to do useful work. So we will try to explain the second law of thermodynamics in the simplest way as possible, yung very basic at madaling maintindihan. Okay? So, but before we go to that, let us dig deeper into this so-called Gibbs free energy concept. So the term free energy is used to get an equation combining the first and the second law of thermodynamics. So it is represented by this equation. Delta G is equal to delta H minus T delta S, in which delta G stands for the change in Gibbs free energy. Delta H is change in enthalpy, while delta T delta S is the change in entropy and temperature. Now, if the delta G is negative, the process is spontaneous. But if the delta G, or the change in Gibbs free energy, is positive, the process is non-spontaneous. So what are the examples of the spontaneous and non-spontaneous processes? So example, when you say spontaneous kasi, kanang it happens on its own. Like for example, you have a hot coffee. So the tendency of a hot coffee, if you put it on top of the table, is that it will gradually become cold. Diba? It will gradually become cold. And another example of a spontaneous reaction is when you when you mix two gases, diba? Or when you mix two gases. And what else? Those are just examples of things that happens on their own. But when you say a non-spontaneous processes or non-spontaneous reaction, example of that is water going up the hill, diba? Spontaneous is when the water goes down the hill, kasi yun naman talaga ang tendency because of the gravity. But when water goes up the hill, that is an example of a non-spontaneous reaction. Another one is the movement of, or the diffusion of molecules from lower pressure to higher pressure. That is another example of a non-spontaneous process or reaction. So yun siya. So now let's go back to our discussion on the three types of reaction. First, you have the exergonic, the second one is equilibrium, and the third one is endergonic. So a while ago, I've already mentioned that when the Gibbs, or the change in Gibbs free energy, is negative, meaning the process or the reaction is spontaneous. And that is the definition of the first reaction, which is the exergonic reaction. Okay? So if delta G, or the change in Gibbs free energy, is of great magnitude, the reaction goes to completion and is essentially irreversible. Now the second type of reaction is equilibrium. So when when there is no change in, when the change in Gibbs free energy is zero, automatically it is considered as equilibrium. And the third type of reaction is the so-called endergonic reaction. It happens when the delta G, or the change in Gibbs free energy, is positive. And the type of reaction that happens here is a non-spontaneous reaction, meaning it requires energy for it to happen, or it requires energy for the reaction to occur. Example of this is when gas molecules will move from low pressure to high pressure. So, yan, energy is required. When water goes up the hill, so yan, energy is also required there. So that is an example of an endergonic reaction, our third type of reaction. So similarly, a reaction may be exothermic if the change in enthalpy is negative, isothermic if the delta H, or change in enthalpy, is zero, or endothermic if the change in enthalpy is positive. So when you say exothermic, so an exothermic process releases heat, causing the temperature of the immediate surrounding to rise. An endothermic process absorbs the heat and cools the surrounding. So example ng exothermic reaction is when you mix two chemicals, or when you mix two substances or compounds in a glass vessel, and after some time you will notice that the vessel will heat up, okay, or the vessel, when you touch it, it feels hot. So the reaction shows an exothermic reaction, as there is a release of heat. Okay, so yun siya, example ng exothermic reaction. So the opposite of exothermic is the endothermic reaction. So for the endothermic reaction, example is, So example of an endothermic reaction is the melting of ice cubes, melting of solid salts, evaporating of liquid water, diba? So yun siya. Those are examples of the endothermic processes. Okay? And what more? So I guess that's all for tonight. We will end with the three types of reaction. Now, if you have any more questions or clarifications about our lesson on the biochemical perspective to medicine, feel free to chat me in my messenger, or you may also mention me in our group chat, or you can send me a message through your Schoology account. So don't worry, because I'm always online from time to time. I'm checking messages of my students there. So rest assured that your queries will be answered. Okay? So also, please support this channel. Please like and subscribe to my YouTube channel for more science videos, for more videos relating to our lesson. Usually, I'll be posting my discussions here. And for you to watch it in your most convenient time, you may rewatch it if you want, if meron ka hindi naintindihan. And yun lang. So, goodbye and see you in the next video.